Hello. Today we're going to talk about keeping it real time with OCI GoldenGate Stream Analytics. My name is Alex Kotopoulos. I'm Director of Product Management in the GoldenGate team in the Oracle Database Development Group. And our topic today is why Stream Analytics? How can Stream Analytics help you? What is it all about as opposed to traditional analytics? First of all, Stream Analytics is all about speed. So if you have stream analytics, you want to drive the information, the real-time information you have to actions as quickly as possible. So you take the events that are coming in that might be from devices, from IoT sensors, they might be from database transactions, might be from business applications. You want to take this data, you want to process it and infer actions as quickly as possible. Might it be through rules? Might it be through machine learning scoring? Might it be through logic and enrichment and correlation of events? You can do this in real time with minimal latency from the creation of the information to the action. If you compare this to batch analytics, in batch analytics, you first write your business data to OLTP operational databases, transactional databases. Then you run batch ETL processes overnight or in certain intervals. You write it to a data warehouse, you write it to a data lake. Then this data is going to be queried in order to produce reports. These reports are going to be read by decision makers who finally will then drive decisions and actions. And this can take its time. It can be hours, it can be days. And in a lot of times, this is good. This is the way it should be. These are aggregated reports that might be over days, weeks, or months and give a full picture over this time. So this is just what you want. But in a lot of other times, the time is of the essence, and you want to get the actions as quickly as possible based on the information that was just created. If you look at stream analytics, how it works, you have all these different sensors, these different sources coming from transactions from databases, application events, and then you want to work on this data. You want to filter out the noise. You want to normalize it to a standard format. You want to enrich it with additional information that you have in other data stores that will add more sense to the data that's coming from sensors. You want to aggregate the data. You want to geocode it. You want to provide more geographical information based on the raw information you have. You want to correlate multiple events. You want to look at the data that you're getting in windows in order to see if there are certain occurrences that make sense when you look at multiple events at the same time. You want to identify anomalies. You want to identify outliers. You want to identify trends. You want to predict what's going to happen. You want to do machine learning and AI based on this data in order to see what kind of things can you deduct, what can you infer from this information. And finally, once you've done all of this, there are different ways how you can use this data. First of all, you might want to visualize it in real-time dashboards through charts where you can see what's happening to the data. You can use it through actions where this is driving specific actions. Can be as simple as, for example, where you get alerts, where you get notifications, or they could drive offers or warnings. They could drive specific corrective actions, such, for example, to lock a fraudulent user or to change the inventory of your system or to drive certain optimizations in your overall processes. And finally, you might just want to pass on the process data downstream, either to data stores or as events through other applications that work on it on real time. In this case, this is streaming ETL, where you take data, you extract it, transform it in real time, and load it somewhere else for further real-time processing. There are a lot of business use cases for stream analytics, starting with IT and data management, where IT is using stream analytics for its own purposes, where it uses it for ingesting data into data lakes and data warehouses and transforming it through the streaming ETL that we just saw. You can also use it in order to control and observe your own processes, your logs, look for anomalies, look for failure situations, and act based on it. In vertical business cases, there are all different kinds of industries that make advantage of stream analytics. And we're always excited in our work that we see new use cases popping up on a daily basis from our customers that we haven't even thought about. In financial services, very popular is real-time personalized offers, where based on the financial information and financial transaction of your customers, you can offer new financial products, you can offer things like credit increases, you can offer new capabilities, and you can involve third-party companies that provide their own offers. So you can monetize this information directly with your partners. Also very popular in financial institutions is anything involving risk and fraud, where you can detect anomalies and react to it immediately, especially in financial situations. You want to immediately detect and shut down these situations rather than wait and act on it later. So these are all capabilities, and a lot of it also translates to other industries. Looking at transportation, transportation often involves geographic information, where you have vehicles that are moving. Might it be cars, might it be trains, might it be planes or other vehicles. You can correlate this information. You can in real time track your assets. You can look at anomalies. You can optimize your processes. You can prepare for arrivals. You can work on departures. So in a lot of cases, we, for example, have customers that use it in airports, where your equipment on the ground is controlled through transportation, through your streaming analytics, so you can control and manage them. We have use cases where railroad companies are tracking their rolling inventory. So a lot of use cases you can use in transportation. Same with telecom, where you have 5G networks producing a lot of data and metadata. This can be processed, can analyzed, can work to help your customers optimize your network. And, for example, prevent customer churn and disappointment by helping customer service, and also overall increase security around your environment. So all of this translates into a number of different businesses. It usually involves your customers, it involves your inventory, your cargo, and involves your equipment. You want to make sure that you will find any opportunities, you will find and mitigate any kind of risks. And this can be done through stream analytics by analyzing the data and information you can get in. GoldenGate Stream Analytics is our offer for solving these stream analytics problems. And we provide a service as well as an on-prem product that will allow you to process any kind of streaming data if it comes from relational transactional systems, where it can be captured through GoldenGate, or it comes directly from event brokers such as OCI Streaming or Kafka, or it comes from legacy environments such as JMS or MQ capabilities. We can take the streaming events in, we can process it, and we'll process it through graphical pipelines that you can see here on the screen. And the great thing about it is it's low code, no code. So you can drag and drop these pipelines. You can build them up graphically, which makes life much easier. You don't have to be a programmer to work on these pipelines. Finally, when you have processed your data, you can write it out. You can either write it out to stores, you can write it out to notification services. You can write it out both to Oracle environments as well as third-party environments, to third-party clouds, to third-party on-prem capabilities. We have a wide array of options how you can process your data, both relational databases, data lakes, object stores, other event brokers. So there you have a wide array of capabilities here. Looking at the differentiators from GGSA or Stream Analytics, the biggest, I would say, is our no-code, low-code environment, where you can build up your pipelines just through editing it from nothing. And you'll see this in our demo later on. And this is important because it saves you from having to use very highly skilled programmers to create your pipelines, which is often necessary with other streaming environments. You can use this, you can even use business users who can work with these pipelines. It's already easier to understand these pipelines. You can change the pipelines. You can even create new pipelines with very limited technical skills. Another point here is pipelines are often created by consultants who then leave, and you have to maintain these pipelines. And it's much easier if you can understand a pipeline like this in a self-explaining environment rather than if you have a lot of programming code that you have to maintain over the years. We provide time series analytics where you can analyze the data coming in, you can see trends, you can see anomalies. We provide real-time dashboards where you can visualize your data, both while you're creating the pipelines as well as later where you provide dashboards to other users. In this case, you can provide dashboards directly from our product, or you can integrate with outside dashboarding software such as Oracle Analytics Server or Analytic Cloud, or you can, for example, use Grafana or other real-time dashboards. And you can also use rule-based decisions where we're using patterns, and patterns is something special that we're offering. These are packaged algorithms that have capabilities such as detecting correlations between multiple events. For example, if one event reflects a door opened and another event reflects a door closed, we can correlate these two and see that they're happening within a certain time frame. If not, you could, for example, warn against this. This is a new event that needs to be looked at. And so any kind of sequences of events, any kind of outliers in data, any kind of special situations, you have a wide array of algorithms that you can use for this. Another capability is the geospatial analysis, where you take geocoded data. And this is very frequent now with mobile apps. You often have geographical information with everything you do, and you can analyze and correlate this information. You can use it within your processing, which we're going to do in our demo. And you can, for example, have geofences to restrict the events to a certain area. You can detect direction, you can direct speed, you can correlate it, you can correlate multiple events with each other, whether they are in close proximity with each other. So there are a lot of ways to working with geo information. And finally, we have predictive analytics and machine learning. So you can integrate with a number of ML standards. We can work with Oracle machine learning within Oracle databases. You can import models from your favorite notebook through PMML and Onyx and run it as part of our pipelines. So this helps you to take the data and score it through pre-trained models to get recommendations or to get predictions. For example, if you have predictive maintenance where you can predict failure of certain equipment. So this is very useful in a lot of use cases. We provide our product in 3 different distribution types. This makes it flexible as well as very easy and managed to use. You can, for example, use our installer-based GT Stream Analytics and install it on-premise or in any third-party cloud. And this makes it also flexible for you to create hybrid architectures where you have the Stream Analytics application on one environment and our Spark processing environment or Kafka event environment in other locations. So, for example, have one thing in one cloud and the control application in a different cloud. So and a lot of our customers do these kind of multi-cloud or hybrid cloud environments. And this is possible, but it's also possible, for example, to use our OCI Marketplace, where we have a pre-installed virtual machine that you can use, that you can combine with multiples to clusters. And it has the necessary software already pre-installed, all the dependencies pre-installed, so it's very easy to use. And our highest automation is through our OCI GoldenGate Stream Analytics native service, where similar to autonomous database, everything is packaged and it's auto-scaling, and you just have to go through a console and create a deployment, and you immediately have a multi-node cluster that is scalable to any kind of production environment. So this is high-level architecture of our native service. You see, you can control it through the OCI GoldenGate console. So you come in through the OCI console and configure it. You create your deployments. And then here on the bottom, you can see the architecture of such a deployment. It creates for you under the covers a cluster of different elements. You don't have to worry how this is set together. We're using Kubernetes internally, so it's highly scalable and redundant. We use shared components within this. and this is all transparent to the user. You just use the console as well as the Stream Analytics Designer, which is shared across our different Stream Analytics distributions. So it is not going to be different depending on what kind of distribution you use. You could, for example, move from one to another. You could use hybrid environments between the two. It's all going to be the same. And we can work on sources and targets both within the Oracle Cloud as well as outside of the Oracle Cloud, where you get data in through events and you write it out to a variety of events or stores. Let's talk about a few customer cases. One customer case here is that we have a lot of major banks in the different continents who are using us for real-time offers and campaign management, which is very attractive in modern banking, modern financial institutions, where you can use customer interactions, customer transactions, and based on that, optimize your work with the customer. You can provide offers for new products, financial products, such as new credit cards, new accounts, and you can also provide offers for credit limit increases. You can even provide offers for third-party partners who then provide you with promotions, with coupons based on your specific location, where you basically perhaps are at a point of sale, or whether you are likely to do certain activity. This can all be used, and you can get a custom tailored offer based on that. And all of this can be used as part of the overall processing, and it's very flexible because it is based on these very business-friendly pipelines that can be changed at a moment's notice. Another customer of ours is SailGP, an international sailboat racing league, and this is an interesting concept that involves both IoT and sensor data in very high volume, where you have sensors on these different boats that provides thousands of data points per second that is aggregated in our Stream Analytics environment, over 30,000 data points per second. And also it involves the concept of data mesh, where you have both data providers and data consumers, where you have the data coming in from the boats and you can provide it like a product to a number of consumers. In this case, it might be the boat teams themselves, it might be the umpires, it might be the broadcasting partners who use it in order to provide their broadcasting statistics, their broadcasting information, their leaderboards, and so on, to defense themselves. So you have a dynamic set of consumers who will use your data, and you can use this overall concept of a data mesh of data products not just in such a situation, but in all different kinds of business use cases where you want to be dynamic with who is going to use your data. We also provide Stream Analytics in the Oracle Roving Edge, which is an edge device that can be deployed either fully connected, semi-connected, or disconnected, which means you can run it completely disconnected from the rest of the world. You can run it with low bandwidth network connection, and you can process it independently. You can process the data and then upload only very limited information and wait with it to upload the rest of the information later on. This makes it very attractive, obviously, for government customers who can use this on a variety of vehicles, on ships, on planes, in the field. But it also makes it attractive for industries such as oil and gas exploration, telecom, and others who might have remote sites where you need this kind of edge processing. So this was just a small selection of our customer cases. Let's go on and see the product through our demo and let the product speak for itself. We're now in the OCI Cloud Console, and I'm going to show a video on the OCI GoldenGate Stream Analytics. In this particular demo, what we're going to show is real-time marketing. We're using our overall company called Movie Stream, which you might have seen in other Oracle database demos. This is movie streaming company, much like Netflix or other streaming company, where customers can rent and view movies online. And in this case, we have all the information about movie transactions in a database that we can capture with Oracle GoldenGate extracts and react to it. And we want to do real-time marketing based on this information. We actually are working with a partner company, a national jewelry chain. And because right now it's Valentine's Day season, we want to give offers to customers who are qualified for that, who are in the right regions, who are watching the right movies, who have the right demographics. We have all this information in different database tables. We want to enrich the data with this information and then make decisions and send out offers. Let's take a look here. We're first going and we're going to open the GoldenGate Stream Analytics. You can see it in the tab for Oracle Database. Here we have a GoldenGate here, and this is the OCI GoldenGate service, which provides data replication, data movement, and also data stream analytics in our deployments. Deployments are the central concept of this service. Deployments are logical environments that you set up that are auto-scaling, where you can then run data replication or data streaming as part of these deployments. Opening the deployments, you see we already have a few deployments. We also have connections. Connections are definitions how you can connect to certain sources and targets. In this case, we have databases, we have object storage, Apache Kafka, and also connections within different GoldenGate environments. And these can be shared across multiple deployments. So going back to deployments, let's create a new deployment and show how easy it is. You just have to give a name, an initial sizing, and whether you want to have auto scaling or not. And based on this information, we'll build up our deployment. So you give an initial OCPU count. You can set whether it's going to be auto scaling or not. You will set what kind of license situation you have. If you already have a license you want to bring in, or if you want to be metered by the hour, you're going to set up your network environment. And then you can choose what kind of deployment this should be. In this case, we want stream analytics. And we give an initial administrator login. So we give an administrator username, and we give a password secret as part of a vault in OCI. So this is all you have to do in order to create a deployment. You press the create button, and then it takes a while to create your new deployment. We already have some deployments, so let's skip this and go to the stream analytics deployment. You see here, you see the metrics of the running deployment. You see assigned connections, so which connections this deployment is using. And you can jump to the Stream Analytics console here. So the console provides you with an overview of what kind of pipelines you have, what kind of example use cases you could use. You see here the resources that we have, and you see the different types of objects. And the most important object is a pipeline, where you get data from a stream, you can enrich it, you can join it with other streams, you can process it, and then write it out. All the other objects, such as streams, references, predictive models, these are all helper objects that help you write your pipelines. One really interesting object here is the GoldenGate change data capture. So let's go to this one here and open it up. What GoldenGate change data capture does, it drives capturing from a GoldenGate environment. So GoldenGate is a separate deployment that sets up an extract from a database. So you can pick a database or another transactional system and capture any kind of transactions, insert, update, deletes, and other transactions happening on this system. And we will connect to this external GoldenGate extract, and we will set this up so the transactions are routed into our stream analytics environment. So we're setting up which GoldenGate connection we want. We're setting up which extract and which target trail we want to connect to. And we're also using Kafka as the transmission system in order to get these transactions into our system. Once we have this, we have a stream with activities, this GG activity stream here, and this is going to be used as an input into a pipeline. The next step we do is we create a pipeline here. So I just want to show you how easy it is to create a pipeline. You just give it a name and you select the stream of events that is coming in. So these two things you need, and that alone is giving you a running pipeline. The pipeline editor is opened, and one specialty here is that the pipeline is immediately started upon you opening the editor. and it will show you any kind of events that are coming in through the stream on the input. And you see here on the bottom, there is a steady stream of events coming in. In this case, these are movie events from our movie transaction database. And you see the typical GoldenGate format where you have after underscore. These are changes, these are inserts into your database. You see here on the op type side, you have the eyes for op type for inserts, and you then get this activity and you can process it. So at this point, we don't do anything with this. And we want to start adding stages to this pipeline. The first stage we want to add is a query stage. What a query stage does is it can process the data. It can filter, it can join, it can aggregate, it can filter out different columns. So much like a select from where statement in SQL, it can modify the data. So in this case, what we have done here is we have added a reference named customer as a second input, and we are now setting the correlation condition. So which key fields should be joined to each other. So in this case, we're going to pick the customer ID from the customer with the customer ID from the event. And this way, we are joining the right records with each other. Applying these changes, we immediately, under the covers, redeploy the application, and you see the result right here, where we are joining the right fields. And you see color coding at the bottom, where the green code is coming from the event, and the orange code is coming from the database that has been looked up for. So we're providing lookups here, and the next stage we want to do is we want to add a pattern. I mentioned patterns earlier. Patterns are packaged algorithms that you can use in order to detect trends, to transform, and to do any kind of other operation. So you don't have to code these algorithms in a language such as SQL. You can just pick them up and fill in the parameters and use them. You see change detector, you see patterns such as transforming data, you see geospatial patterns or enrichment of data, a variety of patterns that you can use. In this case, we're going to use a spatial pattern. And let's jump out of this new pipeline and jump into a pre-created pipeline to see what else we will do in this demo. So you see here in this example, we have joined the data. We have joined them not just with the customer, we also added two more tables, the genre and the movie. And now we're going into a geofence. What the geofence does is it will filter only events of certain areas on the map. In this case, only areas that are close to a location of a jewelry chain where it makes sense to look for new customers. So out of this geofence, there will be a filtered number of events that only are in these certain areas. First, we need to define the geofence, and we can do that by going into the geofence editor. In a second, let's take a look here. We are getting new info here. We see the data from the different sources. And the next thing will be we're going to the geofence here, and we'll go and we'll take a look at the geofence editor. So this is already the pre-created geofence. We'll use it to add one more area here. So we'll go to the polygon tool, and we'll add Virginia as a new territory here. So we're using just a rough sketch here. You can make it as fine as you want to. You can also import these polygons from database tables. So you can have an organization within database table. You can scale it up to thousands and thousands of polygons if you want to. And this geofence is going to be used here in our pipeline. And you see here on the map all the events that are located within certain areas. So you see here the new Virginia geofence. And you see here on the bottom that the events also are now enriched with information about the geofences itself. You see the individual place names that the events are matched to. This way, in our example, we only have events in the territories we have chosen. The next step in the pipeline, we first prepare the data, picking and choosing the columns, and then we are doing ML scoring. What we do here is we use Oracle ML within our autonomous database, and we're using an AutoML model in order to decide how we're going to train, how we're going to score the information. So we have training data set, and we're using an AutoML experiment called movie promotion. We have trained it. We have a number of different algorithms, and we have a number of different features that have been determined to be driving features. So in this case, we are now using this selected model in AutoML in order to take the data from the events as input and provide a score as a result. And you can see the score in the lower right. For each event, there is a given score. Some are lower, some are higher. And we can decide on a certain threshold where we determine, okay, at this threshold, we think this is a good candidate for our promotion. So we see the scoring. We can now go to the next step where we filter the candidates. In this case, we have chosen 0.05 as the threshold for our scoring. So everything greater than 0.05 will be offered a promotion. And you see now the filtered candidates on the bottom. So they're much less than they were at the beginning, but these are the qualified candidates. We can also create visualizations here on the right-hand side, where in real time can see the correlations of our offers. For example, we have a visualization where we show the score by income. We see there is a correlation. The higher the income, also often the higher the score is. And we see the genres that have been matched. And you can see there's reality TV, romance, and musical. So these were determined by our training model to be good candidates for offers. So this overall is our model. So now we can write it out. We can send the offer. We send an event out to a Kafka topic for further processing the application. And we can store the data in a data lake for further processing, where you can then run analytics on this information and aggregate it and collect it for historical information. This is a good example of stream analytics, how you can use this to take real-time information, process it, and drive it to action in real time. So now that you have seen our product in real life, let's conclude what are the top differentiators that you have with our stream analytics. First, I would say the most important part is the no-code, low-code environment that enables you not just to use skilled programmers, but to open it up to all different kinds of users, to business users who will directly understand and interact with the pipelines, who can understand what's going on with the pipelines, who can modify the rules within the pipelines, be very dynamic and change and create new pipelines as they go. So this opens up and makes it extremely flexible. The second differentiator is our industry strength performance, where we are secure and scalable through the use of proven methods such as Kubernetes, such as Spark streaming, such as Kafka, where we provide horizontally scaled environment that can take on very large volume of data and still be highly available through this. We also provide the pattern library that makes it easy for you to work with very complex environments, very complex use cases where you need to correlate multiple streaming events, where you need to find anomalies, where you need to find trends, and work with machine learning, geospatial, and all different kinds of events. We also make deployment and management in our fully managed cloud environment as easy as possible, where you just have to press a few buttons and you get a fully automated, scalable production environment at your fingertips. So this is something that makes it really easy to go out and provide scalable solutions. And finally, we have an open architecture that is not just bound to one specific situation, one specific cloud, but enables you to deploy in different locations, create hybrid cloud, multi-cloud environments, and be flexible with your overall architecture and infrastructure and topology. So overall, I hope this was helpful, and thank you for your time.